Okay, so for this lab, we're going to do the chromatography portion of photosynthesis. You, depending upon which campus you're on and who your instructor is, you may have done photosynthesis as a video feed, or you may have done it as an online activity. So just depending upon who your instructor was, you may have had a different assignment than somebody else. But I'm going to show you just paper chromatography. So that's this lab right here. It says photosynthesis, paper chromatography. It's 2 pages, front and back. And so we're just going to kind of go through this. The top of page 1 is an introduction. It has the balanced equation for photosynthesis. There's a part for you to draw chloroplast and label some things. And then if you flip the page, the purpose of the lab is there, the background is there, talks about chlorophyll A. So the primary pigment found in the thylakoids is chlorophyll A, and then there are additional pigments, chlorophyll B, the keratines, and the xanthophylls, and that's what we're using this lab for. We're using this lab to actually visualize. So this is a spinach leaf. I have a couple of spinach leaves here. We're going to visualize, we're going to actually extract chlorophyll A, chlorophyll B, the keratines and xanthophylls out of this green. So what you see is green, but not all of the pigments you're going to see are going to be green. So on the materials list, you need a large clean dry test tube. I'm going to put that right here in the test tube rack. You need a cork stopper that seals the test tube. We've attached a unbent, reshaped paper clip to this one, and it actually goes in here and will seal. Okay, and we're going to use this paper clip as a hanging apparatus. It's a hanging apparatus for this right here, which is a pre-cut piece of chromatography paper. And I'm handling it with gloves, not because there's anything damaging about chromatography paper, but again, like so many of the other labs, I don't want to get the oils from my fingers onto the chromatography paper. We need spinach leaves, so you really only need one, but I grabbed a couple. You need access to chromatography solution, so that's this right here. When I fill my tube, I'm actually going to step off camera because I'm going to do this under the hood for protective reasons. Chromatography solution is also called eluting solution. It's 90% petroleum ether and 10% acetone. So highly volatile, highly explosive, and it evaporates into the air very, very quickly. Okay. You need a pencil. You need your wax pencil from your bins, which I've got, a quarter, so I have a quarter, a ruler, and then obviously the test tube rack that I've already put the test tube in. So there is a caution on your experiment for the procedure. It talks about chromatography solution being toxic and flammable, and to not breathe the fumes, and that's why I'm going to fill the test tube to our desired mark under the hood in the prep area. So we're going to gather our materials. We're wearing goggles and gloves, and I'll put my goggles on when I go use the chromatography solution, but I'm going to leave them off for now because it makes it difficult to do everything that I'm doing. We're going to attach the strip of chromatography paper to the hook and stopper apparatus. So basically what I'm going to do is I'm just going to choose a spot on here. I'm going to draw a little circle just as a guiding mark for myself with the pencil, and I'm going to use that, and I'm going to poke a hole using the end of the paper clip, and I'm going to poke a hole through there, and I want this just so my chromatography paper hangs from my paper clip. Now I'm going to put it into my dry test tube. What I'm doing is I'm measuring. Because the next part, I want to put this down so it's nice and level, it's well stoppered, but the problem is at this level, my chromatography paper is touching the bottom of the test tube, and I don't want that. It is not touching on the sides, but it is touching on the bottoms. So I'm going to move the stopper hook up so that I have the paper up from the bottom of the test tube. Okay, So all I'm going to do is I'm just going to pull this up a little bit so that it's not touching the bottom or the sides, and I'm going to actually bend mine over so that I can maintain that same height as I work. And as I look at this, I'm thinking, you know, I think that maybe it is just a little bit crooked and maybe I am touching the sides. So I'm going to go ahead and pull this out, and I'm going to use a pair of scissors, and I'm going to trim this just a little bit. I'm going to make this just a little bit more narrow. That's something you might actually have to do in lab as well, because even though we pre-cut them, sometimes they're not quite the way we want them. So then I'll go ahead, and I'm much more happy with that result. So I'm good. Okay, so once I've done that, it says to step number 4, remove the stopper, the hook, and the paper setup from the test tube. We need to use a pencil now. No pen, no crayon, no marker, because those will actually diffuse with the solution, so we need to use a pencil specifically. And we're going to measure 1 centimeter below the hole where the hook attaches to the paper. So I can actually take this off if I want. I'm going to measure 1 centimeter below that, and I'm going to make a dark pencil line. So I'm going to put this here, I'm going to measure 1 centimeter below, and I'm going to create a dark pencil line. Okay, it looks like that. Hope you can see that. Okay, 4B says measure 1 centimeter below the hole where the hook attaches to the paper. Mark it with the 1 centimeter, that's what I did. 4C says measure 2 centimeters from the bottom of the paper strip and mark the paper with a faint pencil line at 2 centimeters from the bottom. So I'm going to go to the bottom of the paper strip, and I'm going to kind of straighten this out so I'm kind of squared up, and I'm going to go up 2 centimeters, and I'm going to make a really light pencil line here. And I'm actually going to do it on both sides, and I can see through my chromatography paper, and I'm just going to draw another light line there. Okay, so now I have the dark line up top, and I have a light line down below. Okay, then it says to reassemble the stopper, hook, paper, and test tube. I'm going to poke that back through. I'm going to reassemble. Okay, now I just make sure that I'm still in there, and I just put a tiny little red mark on my stopper so that I know to put it back in at that same depth, that I know that I'm minimizing as many variables as I can. Okay, number 6, with the stopper in place, use a wax pencil to mark the outside of the test tube 1 centimeter below the pencil line on the paper. Okay. So 1 centimeter below the pencil line. So this is kind of, you're going to got to eyeball this one a little bit. Go 1 centimeter below. And remember, we've struggled at different points in the semester. I don't like where that mark is, so I'm just going to kind of rub that off and try again. I'm happier with that. So let's see if I can show that to you. Let's try. I have a red line on that test tube. Okay. I'm going to set the test tube in the rack so that it doesn't fall to the side. So it stands up pretty straight right there. I want to ensure that I have that ability. If it were tumbling over to the side, I might use a little bit of paper towel to hold it up. I might just practice getting it set in there so it's going to set. The reason we're doing that is we want it to be as vertical as possible while we're running the experiment so that we're not getting the fluid in the tube to run at an angle and actually cause an issue. Okay, so then we're going to take a spinach leaf and we're going to fold it up. Okay, and we're folding it up to create multiple layers. It's nothing about the creases. We're not concerned about the creases we're making, but what we're trying to do is we're trying to get multiple layers of spinach, because what we're going to do is we're going to rub through those layers of spinach, and we're going to try and get the pigment from these cells to transfer onto the chromatography paper. So we're going to fold it several times. We're going to not unfold it. We're going to take the hook, the stopper, and the paper out. We're going to lay them on a clean paper towel. Just use the paper towel we've had going. So I'm going to lay them down here. And now what I'm going to do is I'm going to lay the spinach on top, and I'm going to use the ribbed edge of my quarter, the bumpy edge, the ribbed edge of my quarter. And what I'm going to do is I'm going to roll it. I'm going to put the spinach here, and I'm going to roll it on that line. What I want to do is use the ridges from this quarter to push the pigment, to rupture the cells, and push the green liquid pigment out of the spinach and onto the chromatography paper. That's my goal. You'll notice in your write-up it says the darker the pigment lines typically result in better results, and that's just because there's more pigment there. So really, truly in class, the trickiest part of this is getting it lined up pretty close to the line you drew. So I'm just going to do this, and I'm going to roll it back and forth, and I'm pushing down and rolling. Okay, and after that first little bit, you can see that I have some green there, so I'm just going to shift my spinach leaf, and I'm going to do that again, and I'm going to keep doing that until I get a dark line. So I'm probably going to move this 3, 4, 5 times. I just want to get a really nice dark concentration here. Some of it, and it's not going to line up perfectly, some of it's going to be a little bit above my line, some of it's going to be a little bit below. I just need to try and get it close and try and keep it in that area. And I can tell you just by how my spinach is behaving, this is older spinach. The stores were not great on even spinach selection today, if that's surprising to anyone. Typically, we have much better spinach options open to us than what was available today, and frankly I really prefer the bags of baby spinach as opposed to fully mature spinach, but you get what you get. Okay, so you can see that I was not super duper neat. You can see that I've got a really thick green area there and a really thick green line. So in a perfect world I would have a nice thin line of green spinach, but I don't. That's not the story I have. So what I'm going to do is I'm going to say, okay, I'm about equal above and below, and I'm still going to use my paper line as my measurement point. Okay, so now what I'm going to do is I'm going to pause the video. I'm going to take this set up back to the hood, and I'm going to take chromatography solution, and I'm going to put it into the test tube up to the level of the wax line. Okay, I'm going to put the stopper back in place, and then I'm very carefully going to bring it back here, and I'm going to put it in the test tube rack. And then I'm going to allow about 10 to 15 minutes for the chromatogram to develop. And then once that happens, I'll pop back in, or actually I'll probably just take a still photo for y'all. And then I'll dispose of the chromatography solution. I will let the paper dry in the hood for a few minutes. Roughly 3 to 5 minutes, and then I'll bring it back and I'll show you our results. So I'm going to pause here. I'm going to fill the tube. I'm going to the red line. I'm going to let it sit 15-ish minutes. When that time is up, I'll take a photo of the apparatus all together. I'll take it back to the fume hood, and then I'll dispose of the chromatography solution. I'll let the paper dry 3 to 5 minutes in the hood, and then I'll bring it back and restart the video. What we have here are 4 separate images from left to right. They are time sequence of the chromatography paper. Furthest left is at 3 minutes. The second from the left is 5 minutes. Third from the left is 10 minutes. And all the way on the right is 15 minutes. Okay, so I'm back. And I can tell just like looking at the screen, you can't really see this great. But we have a really nice designation here. I took a couple of still photos during the process, so I'll upload those as a document as well, along with the time frame. But we did get a beautiful separation of chlorophyll A, chlorophyll B, the carotenes, and the xanthophyll. So it worked out really, really nicely. And what I will do is I will put measurement lines on and I will get it up for you so that you can work with it for your lab. Again, this was chromatography solution using spinach, and thank you. Okay, you have a split image. The chromatography paper on the left is right after the experiment. The chromatography paper on the right is a couple of days later. You can see that it's faded, but that was the paper that I used. It's the exact same paper, but that's when I wrote in the measurements. Bottom baseline is where the spinach was laid down. Next line up is for chlorophyll B, that's at 2.5 centimeters from baseline. Next up is chlorophyll A, 4.2 centimeters from baseline. Then the xanthophylls at 5.9 centimeters from baseline. The fourth line up from baseline is the beta carotenes at 9.7 centimeters, and the top line is the solvent reagent line at 10 centimeters.